Okay, so this is part two of your polar area notes. And thought maybe this should be a separate video. I don't know. Maybe the first one has a fun limit or something, and this one's going to be too much. But take a look at example 4. Find the area inside r equals 3 sine theta, and then outside r equals 2 minus sine theta. So let's see, 3 sine theta is going to be a circle that sits kind of on top of the x-axis, right? Let's see, with a diameter of 3, so something like this, right? Circles, kind of sorry. But then also we have the r equals 2 sine theta. So this is the one that's one of the limacons. I know it's a minus, so it's gonna be on the bottom. It's going to go out to 3, right? Because there's like a 1 in front of that sign. So 1, 2, 3. I know it's going to hit the other axis at 2. And 1 minus 2 is negative 1, right? So it goes the other direction. So this is one of those that it kind of has a little bit of a dimple or something out here. But okay, that's kind of sorry. There, that's better. Anyway, and so notice it says we want the area that is inside that black circle, but outside the red piece. So we're talking about all of the area, I think, out here, right? Okay, now here's the thing on this. I'm not looking at tangents at the pole. What I really need to come up with is those angles that would form the kind of the point of intersection. Like I see a point of intersection here and a point of intersection here. So I need to find this angle and this angle. Okay, so if I want to find points of intersection, I'm going to set them equal. So when does 3 sine theta equal 2 minus sine theta? So I'll add the sine and get 4 sine theta equals 2. So sine is 1/2. And let's see, that's going to happen when theta is pi over 6 or 5 pi over 6, okay? And that kind of makes sense. I can kind of see that these angles are going to be pi over 6 and 5 pi over 6. So here's what I want you to think about. If I were to integrate the black circle, okay? If I were going to integrate the black, so I would say area is 1/2. I'm going to integrate from pi over 6 to 5 pi over 6. If I'm just going to integrate the black one, which was the 3 sine theta, right, and I'll square it, then it's more than just the green. It's actually all of this, right? If I were to integrate inside the black circle, but only between those blue lines, right? But I don't want all of it because I kind of want to take out this part that's down here, right? Well, do you see that this part that's down here is the part that's inside the red circle? So basically, I want to subtract out the area that's inside the red circle between those two lines. So I'm going to subtract out from pi over 6 to 5 pi over 6, the red one, which is the 2 minus sine theta. Now I wanted you to kind of see where each of these is coming from, but because I have the exact same boundaries on these and they both have a 1/2 out in front, I could have made this just be one integral and had the first r squared minus and then this second one r squared. So however it makes sense to you. But again, as I mentioned before, I'm going to give you the answer. If you put that in, we're going to get that the area is going to come out to be about 5.1961. So you can put that in and check and make sure you're doing okay with that. Okay, look at this this last example. So this time I want the common interior of these two circular-ish shapes. So here is the 3 cosine. It's going to sit over here kind of on the right side. Let's see, right side, something like that. Right, so there's my 3 cosine. not my worst circle. And then I've got this one. So let's see, I've got the same numbers, right? The 1 and the 1. It's one of those limacons. So it's on the positive cosine side. It's going to come out to 2. It's going to hit the other axis at 1. And the 1 minus 1 is 0. So it's going to hit right here at 0. So it's kind of that kind of turned sideways heart-ish shape. Something like that. Not bad. And let's see, I want the area that is the common interior, so the part that's inside of both. So I'm thinking all of this inside here. So it's kind of bounded on one side by the pink one and on the other side by the black one. Well, again, I'm looking at these points of intersection, right? I have two curves that intersect, so I'm looking at that angle and that angle. Okay, so let's find points of intersection. When does 3 cosine equal 1 plus cosine? So if I subtract, 2 cosine is going to equal 1. So cosine is 1/2. And when does cosine equal 1/2? That's going to be at pi over 3. And 2 pi over 3, it's going to be negative. So actually it's kind of all the way around at, we could say 5 pi over 3, or I could think of that as negative pi over 3, which kind of makes sense based on what I have drawn. All right, so again, if I were to integrate, let's see, if I were to integrate just the pink curve, if I were to integrate just the pink curve, I would have 1/2 integral, and I'm going to say from negative pi over 3 to positive pi over 3. Then if I integrate the pink curve between the blue lines, I'm only going to get this part, right? I'm only going to get this part. Well, there's more that I want. I mean, you see that other green part? You've got a little sliver right in here, right? But I also want this little sliver right in here. Okay, so here's what I'm thinking. Let's see, let me finish the pink one. So that would be the 1 plus cosine, right? Okay, and that r has to be squared. But here's what I'm thinking. Because of the symmetry, those two black pieces are going to be equivalent. So really, I could just integrate one of them, or find the area of one of them, and then double it. So let's look at this top little black sliver. It's definitely between this this pi over 3 line, but it's also going to be bounded by the other tangent at the pole of this circle. And I'm wondering, can you tell that because the circle lays over on the right side, the tangent at the pole is actually going to be pi over 2 right there. Now, if you're not sure about that, to find the tangent at the pole, you could take your 3 cosine, right, and set it equal to 0. But isn't cosine going to be 0 when theta is pi over 2? So it makes sense that the tangent at the pole is the pi over 2, or this black line. So I'm saying that if I were to take 1/2 integral from pi over 3 to pi over 2 of the 3 cosine graph, right, and that has to be squared, that'll give me that top black piece. But if I actually take this and double it, right, that's going to give me both of the black pieces, and I want to add these two integrals together. That should give me that total. So again, when I put this in the calculator, and you can kind of check my work, and by the way, I have not checked these answers. I mean, I put them in real quick so I could give them to you, but you know, if there's a disagreement, I can always look at them. And so on this one, I came out with the area to be a total of 3.6551. Okay? So the last two are a little more involved. Well, some might say a little more involved, some might say a little more fun. But that gives you something to look at. And so as I mentioned on Canvas, I would like for you guys to go to the homework worksheets that you were doing in class the other day. And remember, part of what I had you do was not only do worksheet number 1, but then I asked you to draw the graphs of the shaded region that was represented for worksheets number 2 and 3. So really, you're all set up to find the area. So like, for example, when you go to number 1, you're supposed to, for today, you are supposed to find the area inside that one petal. So you're going to want to do like we did in the example in the homework. You're going to want to find what are these tangents at the pole, what are these numbers, so that for this one, right, you can integrate from this angle right here, we'll call that A, to this angle right here, B, right, of your r squared. All right, so these are all set up. All you're going to have to do is find tangents at the pole, or maybe when you get over to these last ones, find points of intersection like we did on the most recent examples. Something to keep in mind, like for example on number 3 and number 4, they map out a full 2 pi. So you really don't have to find any points of intersection or tangents at a pole. You're going to integrate on those from 0 to 2 pi. Okay, you can integrate from 0 to 2 pi. So hopefully that kind of helps. And then the other thing I want you to do is, so you're going to find all those areas. Use your calculator to actually do the computation. But then I'd also, on worksheet number 4, if you will work on just number 1 through 6. And make sure you notice on this middle section where you're finding the area, it says to set up the integral, but do not evaluate. So just set up the integral that you would use. Okay? So hope this helps. I'll be back in class, let's see, next week. I guess we don't have class on Monday, so on Tuesday. And I'll see you then.